I'm going to talk about unlocking value by increasing like the liquidity inside of the DePIN protocols. We do that with restaking. Now, restaking and staking, like ultimately, there are many differences between Ethereum that I'm not going to go super deep on, but I'm just going to cover what those enable and how the entire like network works. So what Ramo does, on one side, it basically attracts capital providers. These are in the context of the DePIN networks. So you can imagine token holders of Fluence, Falcon, Jensen, and other tokens that are around. And you have providers which are providing storage or compute and generally want to execute particular workloads. And on the right side, you have the networks which are basically defining the jobs that need to be executed, and they're defining the incentives on which whoever executes these jobs is going to be rewarded. Now, if you look to a deeper degree, what's actually happening here is someone on the top left is taking tokens in the context of Falcon that would be putting tokens into a protocol that is using that liquidity as collateral. In the context of Fluence, that would be committing to run particular cores for a particular time frame, or other networks like LivePeer, it would kind of get like a job that can be executed. While on the bottom left, what you see are providers that are able to execute these jobs. And usually these personas are very different, but the networks, because of how they are designed, they need to couple these two personas into one. So you would have a provider that needs to lock some liquidity, for example, in the context of Falcon, lock that as collateral in order to do the job. Now, connecting these two personas is very inefficient because we are basically talking about two very different kind of people, someone that wants to long on a particular ecosystem and someone that just wants to mine. Usually miners are not super long on networks, and that doesn't work out super well. And we know this because we were at Protocol Labs and we spent probably 2 years trying to like make this process easier. We do everything from centralized lending, working with the Anchorage. We work with many exchanges just to allow miners to borrow and basically use that liquidity to provide the service. Ultimately, the realization was it just doesn't work because these providers care just about extracting some short-term rewards and just getting out of the network, and even borrowing and all of these things are kind of not compatible with that. Now, for the networks, what actually is important is that their jobs are run on a wide network of providers. So you would have a storage job, for example, that needs to be executed somewhere, and they just want to have as many providers as possible. Now, how this specifically works is, in the context of Ramo, is that we divide all these jobs in such a way that the only thing you do is focus on what you can actually do. And what I mean by that is, for example, I have a computer here that would not be able to execute snarks, which are required for you to be part of the Falcon protocol, but is able to execute a storage job. And when I say storage job, I mean like I can store 30 gigs on this computer, but I can't do any computation because, of course, this is a laptop. Now, instead of talking about that, I'm just going to show you the Ramo computer. So what I'm going to do here first, I'll make sure I don't have some trash from my past. So I've cleared off everything that I had on my computer related to Ramo. What I'm going to do now is I'm going to initiate the node. By the way, this is all live today, and I'll let you know how you can download this in a bit. I'll basically create my credentials. What this is going to do is basically going to create some keys, and let's see where that actually happened. You see that I have created these keys, and that happened basically a moment ago. Now I have credentials, and I need to basically start running the node. So I'll run the node. This might be running because I was playing with logs before. So let's do another thing here. So assuming this is running because I disabled a bunch of logging. Oops. Let's close all of this. Now, live demos. Okay. Let's run a commitment. And what I mean by a commitment, I mean now I need to somehow describe what can I actually provide. Is that going to be a compute job? Is this going to be a storage job? And how much of this am I actually committing? The commitments are something that we pioneered at Protocol Labs, and we are seeing that as something that most of the ecosystems are kind of covering today. So should be size. The reason why this is Gib is, of course, this was also a great idea that Protocol Labs had. No one knows what Gibs are, but yeah, that's the unit that we use. Now, assuming that this all works, I should be able to commit 32 gigabytes on this machine. Although I'm going to do something before that, so logs are nice and oops, export. And then I'm going to do this. What should happen is I should be able to start downloading a sector. By the way, if any of you try to do Filecoin, like you'll see like a big requirement for machines with petabytes of storage and machines with terabytes of memory. All of this is abstracted away because we focused on distilling the jobs into compute jobs and storage jobs. While this is happening, what I'm going to do here is I'm going to cover a bit more what's really happening under the hood. So Filecoin is probably the biggest compute network around today. Filecoin does 90% of the compute and 10% of the storage. Unfortunately, the compute to actually do verifiable storage is super hard. You need like a lot of GPUs, but you also need to do something called proof of replication, which is super intensive on the CPUs, memory, and so on. It's probably the most complex snark that you can do. And Filecoin, even though like it's not super well known, is the biggest snark deployment on the planet. Ignore all the L1s, all the L2s based on snarks. Filecoin does a snark for each sector every 24 hours. You have 10 exabytes of capacity. Divide 10 exabytes with the 32 gigs. Let's do that. You have these many sectors online, and you have these many sectors every 24 hours. Of course, there is some aggregation, but ultimately this is the level of computation that is happening. Now, what we do is, since we focus so much on efficiency and we really want to have like as many providers as possible, we allow the providers that can provide only the storage, just do the storage. And what would happen here is that the provider would just do the storage, which I'm basically doing on a laptop on a public Wi-Fi. When this happens, what's going to happen is I'm going to start getting challenged 4K random piece IDs, and I'm going to be able to send these as a job on the compute market generated by the Ramo protocol. What that is going to do is it's going to allow someone to generate these narcs that are then going to be sent to Filecoin. Now, what's interesting is that we did this for Filecoin, but imagine doing this for all the DePIN networks. Imagine having like a job on Fluence, be able to talk to Filecoin and be able to talk to Jensen. For example, you would want to read a bunch of data on Filecoin since it has 10 exabytes of capacity. And you would want to inject that into Fluence, and Fluence should be able to do some ETL on top and then ultimately inject that into machine learning training network like Jensen, or even centralized training, because doing ETL in a distributed context is efficient even though you want to do training like on a GPU cluster that you have locally, because most of your data is not going to be local. It's going to be coming from many places, and you might as well like clean the data before it actually arrives into your data center. Now, why is this relevant? Because as we all know, like ultimately the objective is to commodize the entire activity. And as we get there, and as we get better at commodizing storage and compute, we want to increase the value that we provide for the end users. And we do this by combining multiple workloads into like more useful services. So if you're just doing storage, you're basically competing in a very commodized market. But if you're doing storage and compute and you're able to do things that were not possible before, that's a very different product that we're selling. Now, imagine what can happen in DePIN, similar to what happened in Ethereum with flash loans. Flash loans were not something that we copied from the traditional finance space, but it was a new invention that was only possible because we had like a very unique way of doing consensus. We'll see a bunch of this happen also in DePIN, but it's very important to focus on the interop and allow like multiple networks to talk, which is ultimately our vision. I think with this slide, I'm gonna be done. Now, the best part of all of this is the fact that this same exact daemon not only runs on my computer, but it runs in a data center. The only difference is going to be that instead of committing 32 gigabits of sector, I'm going to commit 1 petabyte, or I'm going to commit a pool of GPUs, or I'm going to commit a pool of NVMe flash, or I'm going to commit a pool of cores on a 64-core CPU, which we are doing with Fluence. I'll leave it with this, and yeah, thanks for coming, and thanks Fluence for organizing this and for letting us be part of this.